Hello everyone. For an example in statistics and probabilities, and in this example it says that a doctor is concerned about the relationship between blood pressure and irregular heartbeats. Among her patients, she classifies blood pressure as high, normal, or low, and heartbeats as regular and irregular, and finds that 16% have high blood pressure, 19% have low blood pressure, 17% have an irregular heartbeat. Of those with irregular heartbeat, 35% have high blood pressure, and of those with normal blood pressure, 11% have an irregular heartbeat. What percentage of our patients have irregular heartbeat and low blood pressure? So, what they're asking is, the question is to find a percentage of people who have a probability of regular heartbeat and low blood pressure. This is the question. So I wrote on the side everything that we are given, and those we are not given that are already calculated by default. So we are given that probability of high blood pressure is 0.16, probability of low blood pressure is 0.19, probability of irregular heartbeat is 0.17, probability of high blood pressure given irregular heartbeat is 35% or 0.35. Probability of irregular heartbeat given normal blood pressure is 11 or 0.11, and the probability of normal blood pressure is 0.65, which I calculated from the high and low blood pressure that they gave me, and the probability of regular heartbeat is 0.83 from what they give us as irregular heartbeat. So now, the first thing we need to find is the probability that the regular heartbeat given normal blood pressure. And we have a formula, that the conditional formula, the inverse, I would say, formula, it is 1 minus, we are given the probability of irregular heartbeat given normal blood pressure. So we can find the regular heartbeat given normal blood pressure. So it will be 1 minus the probability of irregular heartbeat given normal blood pressure, which is 1 minus 0.11, which equals to 0.89. So we got that so far. Second thing we need to find is the probability of normal blood pressure given regular heartbeat. Now, normal blood pressure, probability of normal blood pressure given regular heartbeat. And that one, remember the multiplication formula, but we know that it would equal to, in this case, it would equal to the probability of normal blood pressure times the probability of regular heartbeat given normal blood pressure over probability of regular heartbeat. And this is one of the formula, or the multiplication formula, that, or rule, that we have that we can use in this example. So the probability of normal blood pressure is equal to 0.65 times the probability of a regular heartbeat given normal blood pressure, which we just found is 0.89, divided by the probability of regular heartbeat is 0.83. And that would equal to 0.697. 0.697. Let's see again. Now, the third thing we need to find, number 3, we need to find the probability of regular heartbeat, given the high blood pressure. And that will be equal to, as we are given already, we are given the probability of irregular heartbeat given the normal blood pressure. We are given, yes, because if you have a probability of irregular heartbeat given high blood pressure, then you can use that. So what we're going to do is we're going to use the inverse formula with the multiplication rule. So that would be equal to 1 minus the probability of irregular heartbeat given high blood pressure. Now that would equal to 1 minus, now we're using the multiplication formula, which is the probability of irregular heartbeat times the probability of high blood pressure given irregular heartbeat. That's the wrong term, actually, I'm using right now. Irregular heartbeat, divided by, yes, that's also not including this one, yeah, divided by the probability of high blood pressure. And now that would equal to the, let's see, okay, that would equal to 1 minus 0.17 times 0.35 divided by 0.16, and now we go to 0.628. Now, by conditional probability, we would have the probability of high blood pressure given regular heartbeat equal to the probability of high blood pressure times the probability of regular heartbeat given high blood pressure over probability of regular heartbeat. And that would equal to 0.16 times 0.628 over 0.83 equals to 0.121. Now, the question asked was to find the probability of regular heartbeat and a low blood pressure. So we need to find the probability of low blood pressure. So find the probability of low blood pressure given regular heartbeat. And that would equal to the 1, again, inverse formula, minus the probability of high blood pressure it would be probability of high blood pressure given regular heartbeat minus the probability of normal blood pressure given regular heartbeat. That will be equal to 1. That will be equal to 1 minus 121 minus 0.697, which is equal to 0.182. And yes, it's a lot of stuff to do. Now, finally, we can calculate the probability of regular heartbeat and, in the section, low blood pressure. That will be equal to the probability of regular heartbeat times the probability of low blood pressure given regular heartbeat. That will be equal to 0.83 times 0.182 equals to 0.151. That's the probability of regular heartbeat in a section lower blood pressure. Probability of regular heartbeat in a section low blood pressure. And that's 0.151. Yes, this one is kind of hard because there's a lot of formula to use, and you have to know how to go through these formulas and to get to the answer. And that's about it, actually. It wasn't bad. I mean, it's kind of bad because it was not easy, but if you know your formula, you can do it. So thank you for watching this video. I hope you understood. If you like, comment. If you like, thumbs up, thumbs down, or comment. And other than that, have a good day.